Sometimes you're asked to reflect a point over a line that's not an axis. Remember, when we reflect a point over an axis, reflection over the x-axis, the x stays the same and we negate the y. Reflection of the y-axis, the y stays the same and we negate the x. But what about if we're reflecting over a line that's not an axis? So let's try this because there's two approaches, graphically and algebraically. You're going to reflect point negative 6, 4. So let's find negative 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So here's my point, and I want to reflect it over the line x equals negative 1. So remember that x equals is going to be a vertical line, and it's going to go straight through the x-axis at negative 1. Every single point on this line has an x value of negative 1. So graphically, I'm going to go straight across. I'm going to count the distance away this is from the line of reflection. So that's 1, 2, 3, 4, 5 boxes away. And I continue exactly the same amount of boxes on the other side. And then I take a look and see what my new point is. So if this is P, we'll call this P prime. And the coordinates of this would be 1, 2, 3, 4. 1, 2, 3, 4. Okay. That was solving it graphically. But how do I solve it algebraically? Okay, so think about it. We started with negative 6, 4. And we want to reflect over this line where the x value is negative 1. So if the x value is negative 1, that's where we want to meet in the middle. And my y value would still be 4. Well, how did I go from negative 6 to negative 1? I added 5. So I'm going to do the exact same distance to the other side. Negative 1 plus 5 is 4, and I copy down that y value, which is exactly the same thing when I solve this graphically. Okay, try this one on your own. Plot the point, draw the line of reflection, solve it graphically, and then see if you can figure out how to do it algebraically. Okay, and we're back. So first thing we're going to do is plot the point 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. And we're going to call this A. Now we're going to reflect it over the line y equals 2, which is a horizontal line, and every coordinate, y coordinate, is going to be a 2 on this. So it goes across. So solving it graphically, I figure out how far away from this line A is, and it's 3 away, and I'm going to continue in that same direction on the other side. That's going to be my reflected point A prime. And what's the coordinates of that? That's 1, 2, 3, negative 1. So the image of this would be 3, negative 1. Well, how could I do this algebraically? Remember, we start with 3, 5. If I'm going to reflect it over the line y equals 2, I'll have the same x value, but I'm going to go to 2 here. So how did I get from 5 to 2? I subtract 3. So I have to go that same amount on the other side. Subtract 3. We keep 3 for your x value, and 2 minus 3 is negative 1, which is exactly what you got when you solved it algebraically. Graphically.